you switch to low-carb or keto diet, you lost fat, your HDL went up, your triglycerides went down, you feel great, and then your doctor says to you, your cholesterol is dangerously high. But what if the story is more complicated than that? What if the two people can have the same LDL but having completely different level of risk? Because not all LDL particles are the same, and today I'm going to explain the part of cholesterol that nobody properly explains. Most people have heard of LDL, low-density lipoprotein, HDL, high-density lipoprotein, triglycerides, ApoB, but almost nobody understands what these things actually do, why they increase, and which patterns are actually dangerous. And this becomes even more confusing because on low carbohydrate diets, many people see lower triglycerides, better blood sugar, lower insulin, but higher LDL cholesterol. So should you panic? Well, the answer is much more complicated than it seems. And today we are going deep to LDL, HDL, ApoB, triglycerides, small dense LDL, fatty liver, insulin resistance, and why metabolic health changes everything. So what cholesterol actually does? Cholesterol is essential for cell membranes, for production of hormones, for production of vitamin D, and also for brain function. Now, the role of cholesterol in cell membranes is extremely important. It's actually essential. So every cell is surrounded by cell membrane, and that cell membrane, we can say, is probably the most important part of the cell, because cell membrane controls what enters the cell, what exits the cell, the electrical signaling between the cells, nutrient transport. So all that depends on that cellular wall. And in order to be flexible, in order to be permeable, that cellular wall has to have enough cholesterol to actually perform all these functions perfectly. So without cholesterol, the cell membrane becomes very rigid, and obviously all these important functions, they stall. So the cell is not performing as it should, and eventually changes, mutates, or even dies. And this is extremely important, especially for muscle cells, nerve cells, immune cells, and also heart cells. So just remember that human body contains trillions of cells, and every single cell depends on cholesterol. Another essential role of cholesterol is that is used as a raw material for steroid hormones. For example, testosterone, estrogen, progesterone, cortisol, DHA. And all these hormones, they basically regulate growth, fat metabolism, fertility, libido, recovery, mood, stress response, and obviously energy levels. Another important role of cholesterol is actually production of vitamin D. You have all heard that, because when the skin is exposed to sun, then the body produces vitamin D from cholesterol. So if you don't have enough cholesterol, obviously your body will be deficient in vitamin D, which is absolutely essential for immune function, for bone health, obviously relating to calcium deposits in the bone, muscle function, testosterone production, mood, inflammation control. So vitamin D is actually even more than a vitamin, is a pro-hormone actually. And another important role of cholesterol is actually brain function. Brain is extremely rich in cholesterol. Actually, 22 to 25% of your brain is made of cholesterol. And cholesterol is essential for neuron structure, nerve signaling, synapses formation, then memory, learning, and all other cognitive performances. So basically, your body will die without cholesterol. So I think I just made very clear how important and essential cholesterol is in the body. But important thing to understand is that cholesterol does not float freely in the body. It's always transported. It needs transport particles, and they are called lipoproteins. So there are three main lipoproteins that we are going to talk about today. This is LDL, HDL, and VLDL. So LDL is actually not cholesterol itself. It's simply a vehicle which is carrying cholesterol. Imagine our arteries as a highways, and cholesterol has to be transported by vehicles. You can understand that as taxi services. And this LDL is basically carrying cholesterol, because LDL, HDL also, and VLDL, they are not cholesterol. They are made of proteins. So they are just the carriers. So LDL, or low density lipoprotein, is the carrier. It carries cholesterol from the liver into the all cells of the body wherever they are needed, wherever they are necessary. HDL is also a carrier, but it takes extra cholesterol and carries that back to the liver for recycling. So VLDL is very low density lipoprotein. It's produced by the liver, and it carries many triglycerides. So when insulin is high in the body, more VLDL is produced. Because of excess carbohydrates, sugar, liver produces more triglycerides. And these triglycerides have to be delivered to the cells, which is actually happening via VLDL. So VLDL transports predominantly triglycerides. Now, when VLDL delivers triglycerides to the cells, it changes into IDL, or intermediate density lipoprotein. So that intermediate density lipoprotein, or IDL, has much smaller amount of triglycerides, but as it releases them to the tissues, it changes as well into LDL. So low density lipoprotein actually gets from intermediate density lipoprotein. Now LDL is cholesterol rich, is smaller and designed mainly to deliver cholesterol to the cells. And as mentioned, cholesterol from LDL is used for hormonal production, cell membranes, vitamin D, repair processes. So the pathway is from VLDL, when it loses triglycerides, turns into IDL, which loses further more triglycerides, and finally converts into LDL. And now this is very important part. You need to understand that not all LDL particles are the same. So there is the one which is more dangerous, and it's called small dense LDL. And this small dense LDL is associated with, number one, insulin resistance. Number two, high triglycerides. Number three, inflammation. And number four, metabolic syndrome. Now there is also large buoyant LDL, which is often seen in the case scenario of low triglycerides, high LDL, high insulin sensitivity, and also physically active individuals. So I can give you my example. When I, after COVID, had high cholesterol levels, doctor said, oh, this is because of the COVID. It usually happens that your cholesterol is high, because also I had pneumonia, and the body has to repair the tissues on much higher levels. So obviously don't worry about it. We will check again in 3 months. I went in 3 months, and my cholesterol was still high. My doctor called me and said, oh, you know, you have to come, we have to talk, your cholesterol is dangerously high. So I went there, and they explained to me that this is not good, that maybe I should go on statins and similar things. But then I said, can I see my results? They said, okay, we will send it to you. So obviously I didn't have access to that immediately. They never sent it. Then I went and I did my own private blood test, in which I required all these lipids to be tested, and also insulin sensitivity. So when I got results, yes, my cholesterol was high. I will attach the blood test results so you can see exactly how high it was. But it was high, overall cholesterol was high simply because of high LDL. Now, my triglycerides were very low, my HDL was very high. My insulin, my fasting insulin was very low. It was 1. So all these important markers, especially the ratio between triglycerides and HDL, was absolutely perfect, and fasting insulin was exceptional. So then I studied that a little bit more in detail, got a few books on the subject, and I realized actually what is happening, and it's actually exactly happening what I am explaining to you right now. So in my case, because of low triglycerides, high HDL, physical activity, high insulin sensitivity, the high level of LDL was due to that high level of fluffy, buoyant LDL, not because of the small, dense LDL. And this is something important to understand. Now, let me tell you a few words about ApoB, or Lipoprotein B. So every atherogenic particle carries ApoB. ApoB is simply the particle number. It's the main protein found in lipoproteins that can potentially enter artery walls, and that includes VLDL, IDL, and also LDL. So each of these particles carries one ApoB molecule. Now, ApoB is essentially a measure of the number of potentially artery penetrating components in the blood. So it's not just how much cholesterol you have, but also how many ApoB particles they carry. And this is important because ApoB particles have more chances to get through and get trapped within the arteries, causing obviously inflammation and other problems. So let me tell you which things commonly increase ApoB. First of all, this is insulin resistance, meaning that your insulin receptors on the cells are actually closed and they are not allowing enough insulin to get into the cell and deliver amino acids and glucose. And therefore, your body is pumping more insulin into the system simply because it's trying to deliver necessary amino acids and glucose to the cells. The second thing is chronic high insulin levels, obviously caused by insulin resistance. The third factor is obesity. Then you have excess calorie intake. You have high triglycerides. Usually, when people are on high carbohydrate diets, the triglycerides go up. Then you have metabolic syndrome. Also, inflammation causes increased production of ApoB. Diets which combine fat and high refined carbs, and also conditions like fatty liver, when liver produces too much VLDL. So ApoB raises when your body is overproducing lipoprotein particles, especially in metabolically unhealthy states. And what is important to remember is that ApoB may tell us more than LDL cholesterol alone. Because, for example, you can have normal LDL but high ApoB. Or you can have high LDL but lower ApoB particles count. So let me explain now why LDL often rises on low-carb diets. So when you're on a low-carb diet, you're predominantly relying on fat. So that fat adaptation changes lipid transport. So lean individuals develop high LDL, but often, as it was in my case, with low triglycerides, high HDL, and high insulin sensitivity. So on low carbohydrate diets, the body shifts toward using more fat for energy than glucose. And as a result, your liver is producing more VLDL, very low density lipoproteins, which are gradually converted, as I explained, into LDL as triglycerides are delivered to the tissues. In many lean, active, metabolically healthy people, the rise of LDL often occurs alongside low triglycerides, as I said, high HDL, and high insulin sensitivity. But you need to understand that this only applies for this particular scenario, for these circumstances, when you are on a low carb, high protein, medium to high fat diet. So if your LDL is high, but you are not on the low carb diet, then everything I have just said doesn't apply to you. Then you should, check with your physician and make sure that everything is right, because that's not a good sign if your cholesterol is high but you are on high carb diet. So this obviously applies only for special circumstances, which are high protein, medium to high fat, and low carb diets. And this usually happens with people who are exposed to ultra processed foods, consistent snacking, sedentary lifestyle, and chronic insulin elevation. So let me tell you a few words about choline, fatty liver, and triglycerides. So choline is essential for the liver because packages and exports triglycerides in the form of VLDL particles. So without choline, more fat will remain within the liver because liver will not be able to efficiently export this fat, package that fat into VLDL particles, and this may cause fatty liver. And this is why people who don't even drink can have fatty liver, because of inability of the liver to efficiently package triglycerides into VLDL and transport them out of the liver. And interestingly, one of the best foods, obviously eggs, whole eggs, are the highest source of choline. So if you have 4 or 5 eggs a day, you will have enough choline and secure that packaging of triglycerides into the VLDL and efficient export of triglycerides from the liver. So now, should you really panic about high cholesterol? Well, the answer is obviously more complex than many people expect. Context matters. So it's always important to look at your triglycerides, HDL, insulin sensitivity, ApoB, blood pressure, body composition, metabolic health. So the real question is not, is cholesterol bad? But the real question is, in which metabolic environment these particles live. So after 40 years in bodybuilding, competing 46 times, winning 17 titles, coaching over 3,500 clients, I have published for you 12 eBooks, which are fully loaded with detailed explanation about everything that you always wanted to know in bodybuilding. So if you want to learn about training, muscle growth, nutrition, hormones, metabolic health on a deeper level, simply click on that link in the comments and you can download my ebooks. I have also published the Bodybuilding Blueprint course, which is made of 8 videos in which I personally demonstrate and explain the most effective exercises for major muscle groups. So if you want to learn how to train in perfect form, stop wasting time in the gym, start building muscle, losing fat, and avoiding injuries, then my Blueprint Bodybuilding course is your best choice. If you want to access it, again, click on the link in the comments and you can benefit from my Bodybuilding Blueprint course. So guys, I hope that you have enjoyed this video, and if you did, please subscribe to my channel, like the video, share the video, and also send me your comments. And until the next video, I wish you all the best.